Hi, I'm Freetime Coder, and in today's video I'll show you how to take several of the previous techniques to create a PCG actor that places stalactites and stalagmites inside of an area defined by a spline. Also, there are some news at the end of the video, so keep watching if you want to know where things will be going. Okay, to start, we'll create a new actor blueprint, and we'll call this BP stalactites, like this, and we'll add a spline. This will be our area spline for the interior where all the stalactites will be spawning. And to make have a good starting geometry, I'll use the spline generation panel and create a circle with 4 points and a radius of, let's say, 500. That's okay. And then I'm going to select all of these and make sure to move them in the middle. And now I can see the original spline point. I can delete that, and then I'll set it to closed loop, so we have a nice closed spline. And next I'll add a PCG component, and here is where we'll add our graph. So create a new PCG graph, PCG graph, and we'll call that PCG stalactites. I'm going to already put that in here, though it's not going to do anything right now. Compile that, and we're done with this blueprint. Now open up the graph. The first steps will be pretty similar to a previous tutorial I've done, where I'm going to take the spline and we'll just sample a bunch of points inside the spline and then spawn meshes on them. But then I'll combine it with a different tutorial. That was the World Ray Pit Query one, where the stalactites will actually go on the ceiling, and then we'll also have stalagmites that go on the ground. Okay, so first we'll get spline data, and this will get the data for the spline of the actor, since we have the component of, the graph component is in the same actor as the spline component, so by default that'll just take that. And then a sample node for spline sampling, and I'll set the dimension to interior. This means it'll take sort of the area that the spline envelops and puts points on that one. And also I'll check unbounded, because by default PCG graphs are expecting themselves to be inside PCG volumes, and every point, just for optimization's sake, every point that's outside this volume is just getting culled to avoid accidentally, filling the world with a billion points. Since our actor doesn't have bounds and is not a PCG volume, I'll set it to unbounded because the spline kind of acts as the bounds in this case. For this interior sample spacing, that is basically how many points we make. Like every meter in this case would be 1 point. I'll just leave that to 100. And then the next thing I'll do is add a world hit query, and then it's here. And I'm going to use that as a projection target. So not like that, like this. And our sample points will now be projected onto the, I guess, sort of virtual surface that's created by the world hit query. The world hit query by default, I think just traces down, but we want to override that in case we want to trace it one up and one down, so we need to set these parameters. Now for the origin, by default, if we override it, the origin is set to the world origin, which in our case isn't really helpful since our points are wherever our spline will be, and they in no way correspond to the world origin. So I'll have to manually override that. And I do that by clicking this arrow, and then we'll put in a different value into ray origin. And for our case, since we are using an actor, and I'm kind of assuming that the actor's position will be roughly where the spline will always be, I can use our actor's position as the origin. And for that, the easiest way to do that I found is to create a point, or create points, and on the points to create, it'll just stay at the default, which will have a transform of 0, and the coordinate space will set to local component. So what will happen is that the coordinate 0 corresponds to the relative transformation of our component. And then from this one point, we'll get a index property, or get attribute from point index. That's what it's called. So since we're just like, this is basically a list of points, but since we're just creating one point, we know it's just going to be 1 in there. And the index will just be 0 because that's the first point in the list. And for the property type, we'll choose position. So now this attribute gives us the position of the first point in the list, which is just 1. So we'll put that ray origin, and then I can collapse this node again because all the other values we can keep as is. And now we should have at least one set of projection downwards. So let's quickly save this and test it out. For that, I'll put the spline in the scene, and there's nothing to be seen because these are not set to debug display. So I'll hit D, and still nothing to be seen. Probably, yeah, probably because of this. So we'll set that to dynamic instead of static. And there we are. So yeah, you have to keep in mind what you're tracing on. And apparently this block set to dynamic world instead of static world. Yeah, you can see the points are now projected onto the ground. Now we want to do sort of the opposite. So I am just copying these two, hitting Control D, and reconnect all of these things. So this to origin, and then closing it up. In this case, the ray goes upwards. I'm also going to click the debug function, and then I'm going to add a cube shape. So we just have something to hit as the ceiling. I'm going to make this one a little bigger. There we go, and then wiggle this one a little to regenerate the points. This one is obviously static now, so I'm just going to go back into the PCG and set the traces to static, and then the world to static as well. Yeah. There we go. And then wiggle it a bit to regenerate the points. All right, here we go. So we have the same points projected upwards and downwards. And at this point, you may be asking yourself, okay, why go through all this trouble to reproject the same points? Like, couldn't we just use the hit query by itself and then, color volume or something? And there's a reason for that. And that is, we want to create stalactites at the end that have a matching counterpart. So I have some meshes here, and these meshes all have a counterpart. So the stalactite has a matching stalagmite at the bottom. And these are like a few types of different ones, but they sort of all correspond to each other. And that is because in nature, that's also sort of what happens. I mean, it's not 100% because nature is very chaotic, but stalactites and stalagmites grow sort of in the same place, because one is formed by the dripping of the water, like the sediment that gets placed on the surface and when the water like falls off, and the stalagmite is when the water hits the ground and then deposits some sediment there. So you pretty much often end up with both things at the same place. So back in this, what we want to do is at the end here add a static mesh spawner. And all of these points should spawn stalagmites. I think I'll reorder these because these are the floor and these are the ceiling ones. So I think that'll be easier to visualize. Okay, so we have our stalagmites here. I'm gonna add 3 mesh entries. And I am going to assign all of the stalagmite meshes here. So this one, and then this one, and the last one. And then on the opposite side, I'm going to do the same thing. Just going to copy this over. And actually, can I? Oh, that's faster. Okay, so I can replace them with the matching counterparts. So this one is that, and this one is that, and this one is that. Okay. So why, again, do we need to do this? It's because the static mesh spawner, or like this variant of the static mesh spawner, just randomly assigns meshes. And it assigns them by a different seed value. So it's seed value that is part of the point. And actually, if I hit A and then select our PCG actor in the world, I can actually see this seed value. You can see all the different values. So every point gets a random seed assigned, which is nice because then you can make randomizations based on that point that are random but stable. So if you generate different points, or like if you add different kinds of randomizations and then feed in the same points, it'll get the same result every time. So it's like a random stable generation. Okay. Since we are projecting the points that you generated onto the ceiling and onto the floor, that only changes the location in our case, and the seed value keeps the same. So when these points then get fed into the static mesh spawner, the static mesh spawner takes the point seed and generates a random choice between all 3 meshes. But since the seed of a ceiling point and a floor point have the exact same value, it will result in the exact same mesh. And now, well, something's clearly not working, but it should at least give us the matching points. Let me just make it let's generate far fewer points for one. So let's use 500 as the sample distance. That should generate a lot less points. That's too few. So maybe this many, or few, I guess. Yeah, okay. So you can see at least that this and this are the matching meshes. And I think the reason why they are wrong is because, yeah, I clicked project rotations and we don't want that. Oh, I didn't click it, it was already selected. And now it's just projecting the locations, and you can see it's selecting the matching mesh everywhere and gives us basically this result. All right, that is the basic of this tutorial, but now I'm going to just add a few more polishing parts. let's get this out of the way. So first of all, obviously having a bunch of evenly spaced points is not very realistic. So what we're going to do is I'll add a transform point. Transform points. I'm going to put our sample spline points through there. And these values are purely like through testing. I think that's what will probably look good. It's like half of the size of the points. And then also I rotate the points 360 degrees, so they'll be a bit more varied. And then I'll add a scale modifier to them, so we have some smaller and some bigger points. And then let's see how that works, how that looks. Yeah, already more, you can see the different sizes here intermingling, so that's already much better and natural looking. But one more thing we can do is make the outside, or outside in this case, the ones closer to the spline border, these stalactites smaller and the ones closer to the interior larger. And I'll do that by adding another spline sampler, getting its data from the same spline, but in this case we'll not use on interior, we'll use on spline. And this will create points all around the spline curve. And then I'll use a distance node, and I'll take the distance from the border to each point in the spline. And to visualize that and later work with it quite nicely, I'll just set the density. And when we debug this, we can see that I mixed up the outputs. So I'll do it the other way around. There we go. Now you can see everything is black. That means the maximum distance is just way too big, and it's set to 20,000. Yeah, that's way too big. Let's just set it to 1,000 for now. It's still too small. But you can see the ones further in are now brighter, and the ones further out are smaller, darker. So let's maybe do 250. And another thing we can do by default, the distance calculation is done by the sphere bounds. In our case, I'll take the box bounds, and that gives us a much better gradient. And I think I'll increase the distance again. Yeah, maybe 400. Yeah, so that's pretty much the entire range. So from the outside to the inside, we have like sort of all gray values. And then I'm going to do a scale by distance. No, scale by density. So execute blueprint and choose scale density, scale by density, and plugging this into on this node. And we'll set the min and max to 1 first, so you can see it's just nothing. And the scale max to 2, so you can see they are getting bigger in the center, and the scale min to maybe 0.5. You can see they are smaller to the outside. And maybe a little curve in there. So that is a, like, instead of linearly interpolated from one to the other, this adds a small, like a exponential interpolation. And lastly, we'll put that back into our transform points. So let's give everything a bit more breathing space here. And instead of the original points, I'll put these in. And well, that looks nice, but a bit too crazy. So maybe I'll do a slightly less variation thing. There we go. Well, that's nice. Yeah, I think this looks all right. So let's clean up the graph a little. And yeah. So to really see sort of this effect, because one thing that happens is if points cannot be projected, they get culled. So if I move the spline here, you can see all the points that are projected upwards here and don't like hit anything, they get removed. So that only leaves these points. And another nice thing, since we have the spline now, we can basically define any shape. So I'm gonna add a bit more like interesting shapes. And then you can see towards the center, they grow bigger. And then when we have stuff like, you know, a real cave wouldn't be just nice and vertical, but a bit like maybe more chaotic on the ceiling and on the floor. So I'm gonna add a, you know, bit of a fake floor here. And if I regenerate this, you can see this is a much more interesting distribution of stalactites and actually kind of realistic. And you can see here, depending on how interesting your cave shape is, they will also create a very interesting silhouette and outline and all that. Also, if I actually make the ceiling very low, you can see there are basically columns forming now because the stalactites are actually so large they intersect with each other. And that's essentially also how it works in real life. The stalactites just grow towards each other until they meet, and then they melt together into a column. So that's it for the video. Now for some self-advertisement. The channel has grown a lot since I started doing Unreal tutorials, and I'm very happy that so many of you find my videos worthwhile. However, if you have followed my tutorial series, you probably noticed the long breaks between uploads. The truth is, work often gets in the way, so I thought I might try something new by opening a Patreon. For now, it's only one tier that gives you access to the project files of tutorial videos. You can also join for free to get notifications about new videos or articles I write. Link is in the description. I've got a big backlog of things that will hopefully be of interest to you, be it PCG, dynamic mesh, or other Unreal-related content. I've been working with the engine for so long, there's almost no part of it I didn't dive into at some point. Every little bit helps, and I appreciate all of you. So yeah, that's it. Thank you for watching, and I hope to see you soon.